Alrighty, so today we're looking at the last little bit for univariate data, and it's comparing data sets. So what it pretty much is looking at is having two sets of data, or possibly more, and then comparing it by looking at our measures of centre and measures of spread. So with comparing data, I've got a lot of information here which is important to read through. So I'll just go through and highlight some key parts. So the first one, besides locating the centre of data, the mean, median and mode, any analysis of data must measure the extent of the spread of the data, so which means range, interquartile range and standard deviation. Two data sets may have centres that are very similar but be quite differently distributed. Okay, so if you think about two sets that have a very similar median, so middle number, except that doesn't mean that one set could have a really wide spread of numbers as opposed to the other one that has the same median but has a lot of numbers really close to that number. So that's why it's important to measure the spread as well and compare that. So decisions need to be made about which measure of spread and which measure of centre to use when analysing and comparing. Okay, so decisions need to be made. You need to make sure you're using the right one, depending what it's asking for. So the mean is calculated using every data value in the set. Okay, we know that. To find the average or the mean, we add up all of our data and divide it by how many numbers we have. We know that the median is the middle score, so the middle number. So it does not include every individual data. Okay, and the mode we know is the most frequent occurring data value. So it also does not include every individual data value. Okay, so out of that, to take out of that, the mean is probably the most important because it does calculate or take into account every data value in the set. With spread, so the range is calculated by finding the difference between the max and the min. We know that. But the problem with that is that it includes outliers. Okay, so that can really skew the spread of your data, okay, if you've got a really big one or a really small number in your set. It provides only a rough idea about the spread of the data and is inadequate in providing sufficient detail. Okay, so we don't really use range that often. It is useful when we're interested in extreme values. So say for temperatures, if you really want to know high and low tides, that is important to find the range, the highest and lowest. But the interquartile range is the difference between the upper and lower quartiles, so you get a better idea of that middle 50% of your data and the middle range. So that's probably a better one. But with doing that, again, you don't include every data value in the calculation. So it does have a problem with the outliers skewing the data. Okay, the important one, the standard deviation is calculated using every data value set. Okay, so like the mean up here, standard deviation measures spread and it includes every value or data value in the set. So it's important to use those two, which takes into account all of the data. So when you're comparing sets. So let's do an example. I'll get a pen. Okay, for the two data sets, A, calculate the mean. Oops. So let's call this first set x1 and this is x2. Okay. So the mean, so we denote the mean with the x with the little hat on top, and it's the first set. Okay, we're going to add up all our numbers, 6 plus 7 plus 8 plus 9 plus 10. We divide by how many numbers we have, which is 5. So you should get 8 when you do that. Okay, then we find the mean of our second set of data. So we're going to add up all these numbers and divide by how many we have, which is 5 again. And again, you should get 8. Okay, so that's A. We've calculated the mean for both the sets. For B, we've got calculate the standard deviation. Okay, so we've got that really big long formula that we use. So standard deviation is this little symbol of the first one. Okay, so we need the square root of our first data, so 6, and we subtract the mean, okay, which is 8, and we square that, and then so on with all of the numbers. So you would have learnt that yesterday with Miss Tao. 8 minus 8 squared plus, how am I going to fit this all in? 9 minus 8 squared plus 10 minus 8 squared. And that all gets divided by 5, because there are 5 numbers in the set, and you should get approximately 1.41. Okay, the second one, I'm not going to do the same thing because you should know how to do it, but you should get approximately 3.74 for the second set. So that's A and B done. C says comment on the similarities and differences. Okay, so for this one, your first sentence would be, so for both data sets of the data, for both sets of the data, the mean was the same, 8. So both sets of data have the same mean, 8. However, the standard deviation for the second set, so this one, the second set was much higher. The second set was much higher. And then make sure you put the numbers into your actual worded bit, okay? Was much higher than the first. You guys can do a better job at this. I'm just trying to fit it all in onto the screen, which was 1.41. Then, so what does that mean? This implies, okay, so let's just hang on a second. The difference between, so standard deviation, that's the spread in between, or the average spread in between each data set, okay? So the fact that our second set, the standard deviation was higher, that means that the set of data is more widely distributed. So this implies the second set of data is more widely distributed. Okay, and what you can do is, sorry, over here, you can also add another bit. This is confirmed because if you actually find the range for both sets, so the range for this one is the biggest minus the smallest, so 10 minus 6, which is 4, and the range for this one would be 12 minus 3, which is 9. Okay, so that's confirmed because the range is bigger for this second set and our standard deviation was bigger for the second set. That proves that, yes, the data is more widely distributed. Okay, so yeah, this is confirmed by the range. And then you might need to actually say the numbers 9 for the second set and 4 for the second set. I've run out of room. So that's what we're looking at. So you need to talk about everything you've found and what that actually means. We'll do one more example. So we've got below was achieved by 2 students in 8 mathematics tests throughout the year. So we've got John's scores and Penny's scores. Determine the most appropriate measure of centre and measure of spread to compare the performance of the students. So the most appropriate, like I said in that first slide, the most appropriate for measure of centre would be the mean. Okay, because that uses or looks at all of the numbers. So for this one, we need to look at all of the numbers. And the measure of spread, we need to look at the standard deviation, okay, because that looks at the spread of all the points or all the data sets. So for A, we need to find that for both. So we've got John, his average, so we'll find the mean. The mean is 57. Now, up here, there's a CAS guide and OneNote that you can have a look if you don't remember how to find these, or you can do what we did before. But just to make it quicker, because all we need to know, we just want to know this information quickly so we can get to actually comparing. Okay, that's what we're looking at in this chapter, because you've already been able to find the mean and the standard deviation. So the mean for John is 57 and the standard deviation is 6 for John. And for Penny, you will find that her average is 57.5 and standard deviation is 17.4. Okay, so that's A. Now B says which student had the better overall performance on the 8 tests. So who had the better average is what that one's asking, because the overall performance means, on average, who had the better, higher score. So for this one, we can say Penny, because she's got a bigger average or a bigger number, that means that she scored slightly more than John. So she performs better overall. So you say that, but Penny performs better overall than John by 0.5. You don't even have to say that. You can just say Penny performs slightly better overall than John. Because her mean is higher. Okay. C says which student was consistent over the 8 tests. So what that looks at is the spread, so our standard deviation. So who has the less spread? Okay. So we can look at it's whoever has the smallest deviation, standard deviation, means that their test results were more similar. Okay. So looking up here between John and Penny, John has the smaller standard deviation. Okay, so that means on average his test results differed by about 6. Okay, whereas Penny had a really large one, so her scores, the average in between them all was 17.4, which is actually really large. So consistently, John was more consistent. Because his standard deviation was much lower than Penny's. Oops, that's a name, so Penny's. What does it mean? It means that this means that his test results were closer to his mean score. Closer to his mean score. Okay, so yeah, it's with this kind of chapter, it's all about your worded answers, so your written answers, comparing the data. Okay, you'll get box plots, so you can put two box plots on the same scale and compare them. And you can also get back-to-back stem and leaf plots, or you might get just these examples where they give you the data. And that's it.